Okay, so this is my Kyosho Lazer Alpha in its near final form. I made a video about this recently, how the Lazer Alpha is more or less it is the budget version of the Lazer ZX and the Lazer ZXR, and this would be a really good substitute or competitor to something like the Tamiya Manta Ray or the Tamiya Dirt Thrasher, which is what I have been using for a while at the Vintage Off-Road Nationals. So in the last video, if I remember correctly, I got through the roller portion of the build, and then since then I've been working on the electronics installation and a few other things like picking out what body I wanted. So I'll start with the body, I guess, and the wing. As you can see, I'm using a Lazer ZX body and wing. These are actually from my very first Kyosho Lazer vintage Lazer build that I did years ago, and it's actually the very car that I took parts from to do this Alpha build. I just changed the decal setup on that body because I had a much more primitive decal setup. But anyway, Lazer ZX body, because I want to. Basically, I could buy a Lazer Alpha body and then paint that and do decals and everything, but I figured I already have this body and it looks decent and it's like black and gold, and I'm kind of thinking of going with like a nice black and gold sort of color theme here, which is atypical for my racing buggies. Usually I have a particular paint scheme with the neon yellow wing, but I thought this would look pretty nice. Other exterior features that I didn't get into last time is these wheels. Now, these wheels are made by JC Racing over in the UK, and the reason they're significant to this build is because they're actually for the Optima and the Optima Mid, which means that the wheels actually have a somewhat different offset than the Lazer wheels. Okay, so putting these wheels on actually makes the car a little bit wider than if you put on like vintage Lazer rims. I don't know if I have any, like these guys here, for instance, right? These are a different offset. So if I put these on the car, it'll be a little bit narrower than if I put these on. So this is actually suggests to me that I won't necessarily have to purchase wider wheel hexes to widen the car. I could just use these rims. Of course, I'd have to mount tires specific to these rims. So I have a few sets of these. I have one white set and two yellow sets. So the white, I think, goes a little nicer with the color scheme here. So I think that's what I'll settle on, and I'll just take these tires off and mount electrons for actual racing. So yeah, little tip there. And then let's take the body off, because this is where it gets really interesting. Or yeah, I guess that's one way to put it. So all the electronics I think are done. So what did I do? Oh, by the way, before I get to the electronics, one more point. I have not, as you can see, put an under tray on the car yet. The reason I didn't put an under tray on this particular chassis is because if you do that, basically the screws where you would mount the under tray, like let's say these screws here, these are inset a little bit from the bottommost surface of the chassis, and the same goes for the screws here on the backside. Usually when I mount an under tray, I pick like a few screws that I use to hold it onto the chassis. So even if I didn't use these backmost screws and these frontmost screws, there would still be something of a gap between the under tray and the chassis. So I think what I'll end up doing, although I haven't shown it here, is cut out a Lexan plate here and either tape it or maybe drill one or two holes in particular spots to sort of mount it onto the bottom of the chassis, because primarily what I want to do is protect this LiPo battery. I don't want that getting punctured or anything like that. Okay, so on to the electronics. We'll start with the LiPo cell. So this is an ultra shorty. It's a 2.6 amp hour pack. You could fit a 4.2 in here if you wanted to, but it would take a little bit of extra work. I figure the 2.6 fits nicely in terms of the length between this sort of molded extension. This comes as part of the molded chassis. Okay, so I didn't modify this at all, but it kind of fits between there and the same thing on this side. All I had to do was cut a little slot on this side so I can kind of pull this up like so, and I can use that to sort of slot the battery in. Now, I also had to do some trimming on the inside because the LiPo packs are more rectangular, and the old nickel cadmium packs and nickel monohydrate packs are more elliptical. So I did have to Dremel out on the sort of the tunnel where you insert the battery on the upper inside corners. I had to square that off with a Dremel on this side and on this side. So it was like 4 spots where I had to sort of square that off. Once you do that, and again, you cut, maybe a little hard to see here. See that little slat right there? I just cut that with a Dremel. I kept this side untouched so that it sort of basically stays there, just so I can lift this and then slot the battery in. And there's still a little bit of a gap between the battery and this holder, so I just put a foam spacer in there to hold it in, and that works fine. I don't need to do anything else. So that does it for the battery. For the motor, nothing really special there, although I should point out what gearing I use. I have my notebook here. What did I do for the Alpha? So this is, because of the type of slipper clutch I have on this is kind of a custom setup. I can use Robinson pinion gears if I wanted to. But in any case, this is a 93 Robinson spurs if I wanted to. It's a 93 tooth spur and a 24 tooth pinion. So that gives me a final drive ratio of, a 25 tooth pinion. Gives me a final drive of 8.24 to 1. With a 24 tooth pinion, it gives you a final drive of 8.58 to 1. So if you're using the older style or the more conventional, I think it's a 100 tooth spur gear, then you could sort of figure out the math for what pinion you would need to get the same final drive. You want to be somewhere in the low to mid 8s if you're running a sport tuned motor in terms of final drive ratio. The internal ratio, by the way, for this gearbox is 2.214 to 1. Okay, so yeah, for those of you who know how to do math, those are the numbers you need. Let's see, anything else there? No. Okay, I'm just going to put this notebook to the side here. So that was the motor setup. I did want to make sure I had some cooling for the motor, because on my manta ray I do have a heatsink, but on this, the way the motor mounts is really, really hard to fit a heatsink in here. The motor plate itself is metal. You could say, okay, you get some heat sinking action, but I want some kind of cooling. So I did cut some slots in the body on this side to help with airflow going into the body toward the motor. I also put a fan here, and the way I mounted that was the screw that mounts this, I don't even know what you would call this piece here. It's like a brace for the gearbox. It mounts into it's kind of a plastic post here on this side. I just used a longer screw, and with basically a roller bushing and then a little plastic box here. I just cut like I took one of these servo mounts because I didn't need it anymore, and I just cut it to size, and then I drilled a hole so that way I can mount the fan going this way, and I can take this whole thing and I can rotate it if I want. And so that way the fan blows straight down to the motor through this gap here, okay? And that should give it some nice active cooling. I do have I think that has its own channel on the receiver. So you're going to need, between that, the transponder, the servo, the speed controller, you're going to need 4 inputs for your receiver. Or if you have a Y adapter for the transponder and the fan. But anyway, that's what I did for the fan. Use a low profile steering servo because I want to fit the receiver behind it. If you use a conventional servo, it's going to go out to sort of about here, and so the receiver will have to mount on top of the servo. You can do that too, if if you're not picky. For me, I wanted to mount everything low. Transponder is way up front here, and what is advantageous for me, because I put in these this two-piece upper deck from the ZX, I have a nice surface here that I can work with to mount a transponder or a switch or whatever. So it's pretty nice. On this side is where it gets a little tricky. Here I have a Novak Tempest. This is my favorite among the sort of old style, the vintage DC speed controls. And the reason for that is because of a few things. First, it has a 6-volt 5-amp BEC. A lot of the old speed controls have only a 3-amp BEC. So if you're running a modern servo, you may have glitching problems with a 3-amp BEC because the servo might be pulling too much current. And so, those other speed controls won't be able to supply that much current. This one can. It gives you up to 5 amps BEC. Now, the way I set up the electronics here, the BEC for the speed control is actually irrelevant. I will get to that in a minute. The other reason why I like the Tempest so much is because it has the most powerful brakes. This has 210 amps maximum braking current. I don't know of any other speed control that even gets close to that. Maybe you can get into like the 120 to 180 range, even on other Novak speed controls, newer ones like the Novak Cyclone. They don't have 210 amps of braking current, maximum braking current. Maybe there are some Tekin speed controls, the high-end ones that have achieved that. But if you want something with powerful brakes, the Tempest is a great speed control for that. The other reason why I'm using the Tempest in here, not just because I like it so much, is because of the shape. It's a rectangular shape rather than a square shape. So if you look at something like, if we go over here, this is a Novak Racer. It's the MegaFet version of the Novak Hammer, which is a HyperFet version. This is a more square speed control. This you can't really fit into this sort of bay here where you put this speed control. I mean, maybe there's a way to finagle it in there, but it would be very difficult. And also these heat sinks are, well, actually I don't think the heat sinks are so wide that they wouldn't fit. But see this depth here, the way that I mounted this speed control is along the outer sidewall of the chassis, and maybe kind of as far forward as I can actually push it. So that means the depth here actually almost touches this sort of wall here that contains the belt. So if you have a speed control that goes even deeper than that, like this, the Tempest maybe comes out to here, the Racer comes out to here, this won't really even fit in there. You might have to cut out the chassis to make it fit. So the Tempest is a really good fit. There are other speed controls that have a similar form factor, like the LRP IPC. I think it's also a similar shape. So, be mindful of what kind of speed control you put in there. Now, because this is an older style speed control, you have to be careful about running LiPo batteries in this. In the past, like for example with my Dirt Thrasher, you can get a little LiPo voltage monitor and put it somewhere on the chassis, and if you're running a balance charge cable to the battery, so you have one connector that goes into this middle port here, and then you have your positive and negative leads, and then that little white balance lead can plug into the voltage monitor and tell you the voltage, and then give you an alarm, an audible alarm when the voltage drops below a threshold. That's fine, but it doesn't actually shut the car off. So you can still over discharge the LiPo if you don't hear the alarm. So what I tried to do here is set up an actual cutoff, a LiPo cutoff for these older speed controls. Now Novak used to make something called the Smart Stop, which did exactly that. And you have to do some extra wiring to the speed control to set it up. Smart Stops are very hard to find, especially for 2S LiPo. I found one on eBay, which after shipping is like $60 or something ludicrous. So I figured I'd try to make something else work. And a couple of companies make this. This one is from NHX. You can find this on eBay for like $15 or so. And by the way, there are other companies that sell their rebranded versions of the exact same thing. So I think like ProTech and a few others, they buy this from the original manufacturer, make it a different color, slap their brand name on it, and charge like $30 for it. but this one I believe is the original one. And the manuals for those are exactly the same. So it's literally the exact same switch. Now what this does is you have an input and an output, just red and black leads. So the input comes from the battery, and and this is for a 2S LiPo. If this is in LiPo mode, when the voltage gets to 6.4 volts, it will only supply enough current to run the servo, but it will not let the speed control run and draw, more current from the battery. So the thing is, this does not have a signal port, right? So basically, how do I describe this? This end here would plug into your receiver, but it's just a positive and negative lead. So what you have to do is you have to go to the plug. Let me just find it here. I know it's a little bit funky. I'll just pull this out. So this is the plug that actually comes from the speed control. You can see there's a black, a red, and a white line. Black is ground, red is power, and white is signal. So the speed control is supplying power to your receiver, which then powers all the other stuff that's plugged into the receiver, the servo, the transponder, everything else. It all comes from this power line. And the white is the signal. So there's the receiver sending a signal to the speed control to tell it how much throttle or brake to apply. Okay? Now, if you want to run this LiPo cutoff, what you have to do is take the white signal, the white line, out of the receiver plug for the speed control and plug it into the receiver plug for this LiPo cutoff, and then you plug that in. So that way you're doing a few things. Number one, you're bypassing the BEC circuitry on this because the power is coming directly from the battery. Now this receiver is spec'd up to, I think, 9.8 volts. So for a 7.4 volt LiPo at full charge is like 8.4 volt. It's fine. You're not going to blow out the receiver or anything. And this particular switch can supply maximum 10 amps current instantaneous. So it's actually like a better BEC, if you will, than what the speed control supplies. So that's good. But also, this setup doesn't really require you to do anything funky with the wiring. All I had to do was take this part here, clip the wires, take the positive and negative leads, and just solder them to the battery post terminals. So this fat wire is what goes to the speed control, and this thin wire here is what goes to the switch. Okay, so what I would do, negative is already in, I would do positive. Let me just, oops. Ah, man, I left the radio on overnight. Oh, well. I'll deal with that later. So what you would do is, first thing is you would press and hold this to turn this on. Okay. So this is going to supply power from the battery to the receiver, and you could run, if the transmitter is on, you could run the servo. See the fans running. And then you keep this switch for the speed control, and that will turn the speed control on. Okay, so you need to run two switches. But that's how you would set up a LiPo cutoff without breaking the bank for your old DC speed controls on these cars. Now this is quite a bit of wiring in here. It all fits. It might look a little messy, but it all fits. And I did test run it. It runs fine. So this is essentially what I plan to use. Or what I would like to use for the Vintage Off-Road Nationals for the Classic class this coming year. So we'll see how that goes. Okay, thanks for watching.